Let me do this integral by three methods. The methods are important, are interesting, because these are basic training for techniques of integrations. Now, okay, method one, uh, the denominator can be factored as x squared plus 1 and x fourth minus x squared plus 1. Yeah, okay, good. Then that one, this can be further factored. So this will be integral dx over x plus 1. Now, how to factor this one? Well, x fourth minus x squared plus 1 could be written as x squared plus 1 square, right? And minus 3x squared. So this could be x squared plus 1 square and minus root 3x squared. So this could be written as x squared plus root 3x plus 1 and x squared minus root 3x plus 1. Okay, so we factored. So this is equal to x squared plus root 3 x plus 1 and x root 3 x plus 1. Okay, so my I is equal to you have three integrals now, x squared plus 1, so ax plus b, right? Dx, yeah. Then yeah, plus integral x squared plus root 3x plus 1 cx plus d and plus integral x squared minus root 3x plus 1 ex plus f. Yeah. Then use the comparing of coefficients. You can determine A, B, C, D, E. Now, I believe you know how to do it, so I omit the process. So A is equal to 1/3, B is equal to 0, C is equal to negative 1/6, E, A, B, C, D. D is equal to root 3/6, E is equal to minus 6, F is equal to root 3/6. So then we plug A, B, C, D, E into the integral. So I is equal to 1/3 dx x squared plus 1 for the first one. For the second one, we combined the common factor, so it becomes a plus 1/6 and CD, right? So it's a minus x plus root 3 square plus root 3x plus 1. And for these two, a common denominator, common factors, this is x plus Well, from there onward, I believe that everybody can do it. This is just basic integrations. So I stop here because see nothing new, nothing more interesting there. So okay, this is method one. Now method two. Uh, okay, method two. Method two for the integral x6 plus 1 dx. Now that one is equal to integral, okay, x squared plus 1, right? Then x fourth minus x squared plus 1. That is obvious. See, method two is that, well, it's clever. We do not further factorize this, but rather consider here x squared as a unit. So if we consider x squared as a unit, so this is a linear, this is a quadratic. So this is a, this is a b x squared plus c. Yeah. See, we don't have to further factor this. We consider that one is a, is a quadratic. Then we can find ABC, right? So I omit the steps to find ABC. Is A equal to 1/3, B is equal to negative 1/3, C equal to 2/3. So my integral is becoming 1/3, right? 1/3 dx of x squared plus 1. That's for this one. And for that one has a common denominator, a common factor is 1/3 and x squared minus 2, yeah, x fourth. Okay, good. Now I discussed this one separately. I discussed this one. This is okay. This is x squared minus 2 x fourth. If you excuse me, and okay, I continue there. This one, uh, instead of doing something for denominator, I'll do something for numerator. Fourth minus x squared plus 1. This is dx minus 1 plus e to x squared plus 1. I'm going to decompose the numerator into this form. So this could be done, right? Let me do this one here. This means d plus e is equal to 1, right? And minus d plus e is equal to negative 2. Right? So from which I can find that d is 3/2 and e is equal to negative half. So my integral has been my integral becomes this is a common factor. integral x squared minus 1, x squared x fourth minus x squared plus 1. So dx, that is for this one. And the other one, common denominator is a 1/2. And this is x fourth minus x squared plus 1, x squared plus 1. Okay, good. These two integrals are better to do because this one, for example, this one, x squared minus 1 is equal to, now I divided x squared both top and the bottom. So this one is 1, this is 1 of x squared. This is x squared minus 1 plus 1 of x squared. For that one, I do the same thing. Minus 1/2. I divide by x squared. This is 1 plus 1 of x squared dx. This is x squared minus 1 plus 1 of x squared. Okay, and this could be done for this could be done, like this, x plus 1 of x. Then the denominator is to reconstruct x plus 1 of x as a variable, which is possible. And this midterm is minus, the midterm is a 1. This is minus 2, minus 1, so it's minus 3. Right? Minus, this one is dx minus 1 of x, right? So well, changing the denominator into a function of x minus 1 of x, which is possible, right? The midterm is 2, is minus 1, so plus 1. Yeah, so this one is equal to, this one you have a formula, right? No. What am I doing? This is 3, this is 2 root 3, natural log x plus 1 of x minus root 3. This is x plus 1 of x plus root 3. See, for this integral, we have a basic formula. For that one, it's minus arctangent x minus minus x, right, plus c, yeah. So then we simplify a little. So this will be root 3 to natural log times x, squared minus root 3x plus 1, x squared plus root 3x plus 1. And yeah, minus half times x minus x1 plus c. Okay, that is for this integral. And that is this integral times 1 minus, so my I is equal to this minus 1/3 of that. So my I is equal to this. This is 1/3 of arctangent x, that is this one, minus 1/3 times this one. So 6 log x squared minus, that is this one, times 1/3 become plus 1/6 arctangent. Yeah, so that is the answer for the for the integral by method 2, which is good. Now method 3, this is the best method, I guess. Dx x6 plus 1. Now this method is, I think, is the best, because now I let this be called I bring integral j, which is this, x4 x6 plus 1 dx. Then I plus j is equal to this one plus this one, x. I factorize this, becomes x squared plus 2. This one is x4 minus x squared plus 1. Okay, I can do this. I can minus x squared plus x squared, right? Which means the same. And then this one over that one plus x squared over that one, right? So this becomes integral. This one over that one becomes this, right? This is cancel with that one. Now for the next one, plus x squared x6 plus 1, right? That this one is this. It's much better, much easier. Well, this one, yeah. The other one is equal to, this is x cubed squared plus 1, right? And the numerator is x dx cubed times 1/3. See, that's the same thing as this. So this one is equal to arctangent x plus 1/3 arctangent x cubed, right, plus c1. That is I plus j. Now j minus I is this. This, right, x 6 plus 1. Yeah. This one equal to the numerator is x squared plus 1 and x squared minus 1. Yeah. Okay. And the denominator is x squared plus 1, x fourth minus x squared plus 1 and dx. Yeah. Okay. Now, then this one cancel this one, right? This is much easier. This becomes x squared minus 1 dx over x fourth. Then I say, like I did in the last method, I divide by x squared. So 1 minus x squared. So this is x squared minus 1 plus 1 of x squared. So this one is equal to, this is a dx plus 1 of x. And this one changed to x plus 1 square. The midterm is plus 2. This is minus 1. So minus 3, huh? This is minus 1. This is plus 2. Yeah, that's right. So this one is equal to 2 over natural log. Yeah. Yeah, plus C2, right? Okay, good. Then my I is 1/2 of I plus j minus j minus I. So this is half of this, half of a tangent x plus 1/3. That is this. This is f I plus j, and minus this one, minus, yeah, x plus. This could be simplified, huh? Plus c, yeah. And then I think it's not important. Anyhow, this could be done easier. This method is much better compared to the first two. All right.